Good morning, students. Today we talked about the progressive waves. This is the summary that which we are discussing in this topic. The definition of progressive waves. When we produce disturbance in a medium continuously, the particles of the medium vibrate continuously at their place, and disturbance goes on proceeding ahead. So the wave produced in this condition is called the progressive wave, or in simple terms, we can also say that the wave that generally travels continuously in a medium of the same direction without the change in its amplitude is known as traveling waves or progressive waves. There are two types of progressive waves. Transfer waves. In transfer waves, the direction of vibration of particles of medium is perpendicular to the direction of the propagation of waves. It's called the transfer waves. It is also defined as the waves in which the particle of the medium vibrate up and down at right angle to the direction in which the wave is moving. In this figure, we see that the wave produced by the one end of rope is up and down, whose other end is fixed. So it produces the transfer waves. So another example is dropping a stone in a pond of water. Next is the longitudinal waves, in which the wave particles of the medium vibrate back and forth in the same direction in which the wave is moving. Here is the example of the longitudinal wave is spring. The wave can be produced which travel along a spring when it is forced and pulled are longitudinal waves. When we pull the spring, so it's produce a rarefaction, and when we push the spring, so it compressed. So in longitudinal waves, we find the compression in the rarefaction. This type of waves are called the longitudinal waves. Another wave is the orbital waves. A progressive wave that moves in circular motion is known as the orbital waves. Ocean wave is a classical example of the orbital waves. Progressive wave equation. And in progressive wave equation, the energy is transformed one place to other by the vibration of particles of the medium. So this equation generally formed to represent the displacement of particles that is vibrating in a medium through which a wave passes. For this, let us consider a wave is moving or propagating in a medium along the direction of positive x direction, and the origin or the source of waves is O. Then the displacement of the particle in this figure, the phi shows the phase difference. It's 2 pi x by lambda. So this displacement of particle at a given instant is y is equal to a sine omega t. Here a is the amplitude and omega is the angular frequency. The displacement of the particle denoted by the letter p, and the distance x from O at given state, it's y is equal to a sine omega t minus phi. This is equation number 2. If two particles are separated by distance lambda, so they will differ by the phase phi. So the phase of particles p at distance is x is y is equal to 2 pi by lambda x. So equation becomes y is equal to a sine omega t minus 2 pi x by lambda. Here omega is the angular frequency, so omega we can write as 2 pi nu into lambda, nu by lambda. So equation 3 will become y is equal to a sine 2 pi by lambda nu t minus x. We know that omega is equal to pi by t, so we can written as equation 3 y is equal to a sine 2 pi t by t minus x by lambda. This is the equation number 5. If the weighted generally travels the direction which is opposite the equation, so generally it becomes y is equal to a sine a sine 2 pi t by t plus x by lambda. So here the equation number 5 and 6 shows the wave in positive or negative direction. Here is some example of progressive wave like electromagnetic waves. The electromagnetic waves, this is the progressive waves made up of a magnetic field perpendicular to the wave's propagation paired with the variable electric fields. The wave of light is also the example of progressive waves. Sound waves can move in the same direction without changing in amplitude. So it is additionally a good illustration of progressive waves. Next is the water waves. Here are two types of water waves: transfer wave for longitudinal waves. On the other hand, waves in the ocean or lake are the orbital waves that moves in a clockwise. And also the seismic waves are the mechanical waves that propagate outward from a fault epicenter. Here are some numerical question of progressive waves. In this question, given the progressive wave y is equal to 5 sine 100 pi t minus 0.4 pi x. So here we find the frequency and the lambda in this question. So the solution is become the given equation and the standard wave equations we have to compare. So we find the lambda is equal to 2 pi by k. So we can we solve this equation. Here k is 0.4 and omega is 100 pi. When we compare the standard progressive waves on the and given equation, and a is a 5. So lambda we find 5 meter, and the frequency formula is omega is equal to 2 pi f. Here omega is equal to 100, so the frequency formula become omega upon 2 pi. So when we put the value of omega and 2 pi, so we get 50 hertz frequency. So this type we can solve the progressive wave numerical questions. Thank you.